Okay, here we have the Chapter 3 review for your midterm exam. So this is a nice little packet here. Again, I recommend you do more than the questions here to really understand and be proficient with the material. So here, this is just a vocabulary exercise. We want to write the angle measurements, or sorry, we want to name these angles. So angles 3 and 5, we look there, they share two sides. So these are vertical angles. If we look at angles 11 and 12, they're next to each other, they're a linear pair. We can also call them supplementary angles, either or. Just don't call them adjacent angles because that's not specific enough. They are more than just adjacent angles. Angles 2 and 6, we can see that if these are the parallel lines, this is transversal. We can ignore these bottom lines. We see that 2 and 6 are going to be alternate interior angles. 1 and 15, which I just skipped, these are going to be on the outside, so these are going to be alternate exterior angles. You can see because this is the transversal going up and down, these are the parallel lines. So 1 and 15 are both on the outside, the exterior of the parallel lines. 6 and 11 are right next to each other on the inside, so they're going to be consecutive interior angles. And finally, 3 and 13, again, are on opposite sides or alternate sides and on the outside of parallel lines, so these are alternate exterior angles. Make sure you get more practice, so look at it and say, oh well, 10 and 2 are corresponding angles. 7 and 10 are consecutive interior. 10 and 16 are vertical angles. Just keep practicing with this. All right, so this is a good one. We had something very, very similar to this on the test, so we can figure this out. So we know that angle 2 is 50 degrees. And we'll go through this actually fairly quickly. So here, if angle 2 is 50, angle 3 is vertical, so that's got to be 50. Angle 1 is complementary, so that's going to be 130. Sorry, supplementary, so it's 130, as is angle 4. Right here, this is a right angle, so that's 90. 12 is vertical, so that's 90. And so all these other angles, too, are going to be 90 because of supplementary angles. What else could we do here? Well, we know that N and M are parallel, so 11 and 9 are consecutive interior angles, so they are going to be supplementary, so they add up to 180. So that means that this is going to be 90. We also know that we can see that 9 and 6 are vertical angles, so 6 is going to be 90 degrees as well. Here, 50 and 90 add up to 140. So inside this triangle here must also be 40 degrees. 180. So that means that this is going to be 40. Here we have this straight line going across. 40 plus 90 is 130. So this remaining angle must be 50. We can also see that angles 2 and 5 are alternate interior angles. So they're going to be the same. 5 and 8 are vertical angles, so that's going to be 50. And angles 7 and 10 are vertical angles, so that's going to be 40. That's a 4. And so now I can just write these all down. So angle 1 is 130 degrees, 2 is 50, 3 is 50 degrees, 4 is 130. So you can see as I go through these, drawing the picture, really get really messy and sloppy with the picture. Write in pencil so you can erase the mess if you need to, and then just copy down the answers right onto the answer key here. And that's all you got to do. Angle 11, it's 90, and what these last ones are all 90. 13, yeah, it's 90. Cool. That's it. Next up, find the slope. Slope formula is the change in y. So y2 minus y1 over the change of x, which is x2 minus x1. So this is going to be the change in y, which is going to be, we could say 3 minus a negative 8 over the x values, which is 4 minus 7. So that's 3 plus 8, which is 11, over 4 minus 7, which is negative 3. Don't really like to write negative signs in the denominator. The best way to do it is write it directly in front of the fraction bar. So we get negative 11 thirds. Find the slope when it's perpendicular to this. Well, here's the slope, 6 sevenths. So the new slope, m, is going to be negative 7 sixths. Here, the slope for the original equation is negative 1/3. When it's parallel, it's going to be the exact same. So it's going to be, again, negative 1/3. Slope intercept form of the equation here. Well, that's going to be y equals mx plus b. M is 1/5, and b is 10. So there we go. There's the equation, mx plus b. And for these, parallel means that it's going to have the same slope. So we can use Pointslope form here, where we replace the subscripts x sub 1, y sub 1 with the actual values. So y minus a negative 5 is equal to same slope, 2 times x minus 3. So we're going to have y plus 5 equals 2x minus 6. Y equals 2x minus 11. So that's the answer there. And here, perpendicular slopes have opposite reciprocal. So we know we're going to have y minus 9 equals perpendicular to the slope of 2 is going to give me negative 1/2. X minus a negative 2 is plus 2. So we get y is equal to negative 1/2 x. This is going to give me negative 1/2 times 2, which is negative 1. If we add the 9 from both sides, we're going to get y equals negative 1/2 x plus 8. And that is our answer. We have these two. These are alternate interior angles. To make m and n parallel, these must be equal to each other. So we say that 4x plus 8 is equal to 160. So we say that 4x is equal to 152. If we divide both sides there, well, 4 goes into 15 3 times, and that's going to give us 12. With 3 left over, bring that down, so 4 goes into 32 8 times, so x is equal to 38. Here we're going to have 5x minus 5 plus 60 equals 180. Because in order for lines m and n to be parallel, these consecutive interior angles must be supplementary. So we get 5x plus 55 is equal to 180, or 5x is equal to, if we subtract 55 from both sides, we're going to have 125. So that means that x must be equal to, oh boy, it's been a long day. Let's see, 5 goes into 12 2 times, and with 2 left over brings us 25. Okay. Last is the proof. So again, first thing we want to do is we want to write the given statements. Angles 1 and angles 2 are complementary, and BC is perpendicular to CD. Why? Because that's the given. So we want to prove that BA is parallel to CD. Well, if angles 1 and 2 are complementary, that means that this line here, BC, is perpendicular to that line there, BA. We can say that that's because definition of complementary angles, or horrible handwriting. Definition of complementary angles, or complementary angles make right angles, lines are perpendicular, however you want to explain that. We already know that BC is perpendicular to CD, So we can actually already say that BA is perpendicular to CD. And this is actually a theorem we looked at, where if we have a transversal through two perpendicular lines, those lines must be parallel. So if you don't remember the name of that, that's fine. We can actually say, just say what that I just said. So if a transversal cuts through two lines, it cuts through two lines and is perpendicular to each line, those two lines must be parallel. Again, probably a little bit wordy there, so if you remember the theorem name, that's great. But if you just want to put that down, that works. So that's the proof. Those are the problems. Keep on studying.